Welcome back, learners, to Lesson 32, Session 4, Practice Finding Same Perimeter with Different Area. Now, they did give you an example just in case you wanted to review before you started working on your assignment. But let's go ahead and look at what you might have on your paper. Now, remember, if you have something that's different, that's okay. Just pause and find out where your mistake is and fix it. Okay, number 1, they asked us about these two rectangles. And they both have a perimeter of 14 feet. But then they wanted you to find the area. So notice that with a length and a width of 1, we have an area of 6. Because they did 6 times 1 is 6. For our second rectangle, it is 5 times 2, which equaled 10. Okay, number 2. Let's see how you did there. Draw a different rectangle that has a perimeter of 14 feet. Write the length, width, and area in the table. Now remember, we know that perimeter has to equal 14. And since the perimeter is 14, that is the same thing as having a 7 plus 7. Because remember 14 split in half is 7. So one set needs to equal 7 and the other set equals 7. So notice that I chose for a perimeter, I could do a 6 plus 1 and a 6 plus 1. Or I could have done a 5 plus 2, or a 5 plus 2, because these two equal 7 and these two equal 7. These two equal 7 and these two equal 7. So you just had to find a way that they equal 7. Notice up here, they all equal 7. So now I had to find 2 more that equaled 7. What's another way to make 7? Got 6 plus 1, 5 plus 2. I actually kind of go in number order. I used the 6, then I used a 5. What am I going to use next? A 4. 4 plus what is 7? 4 plus 3. And if I use 4 plus 3 here, I have to use 4 plus 3 here. So 4 plus 3 are my new lengths and widths. So 4 feet times 3 feet is an area of 12 square feet. So that's how I figured out my 4 by 3. And I drew it here. 1, 2, 3, 4, 1, 2, 3. Okay, let's go ahead and look at number 3. Number 3 had a lot of work. So I actually did the work over here on the side. They asked which of the rectangles here, A, B, or C, had the greatest area. So in order to answer which had the greatest area, I had to find the area of each one. So for rectangle A, I did 6 times 3 is 18. For B, I did 5 times 5 is 25. And for C, I did 4 times 5 is 20. So then I looked at each of the square units, 18 square units, 25 square units, and 20 square units. And I had to find the greatest. That means the largest. Which of those 3 has the largest area? It was rectangle B. B has the greatest area. Okay, in number 4, they wanted you to find out which rectangles have the same perimeter. Because remember, you can have the same perimeter even though the side lengths are different. So what I looked for is the perimeter of A, B, and C. A has a perimeter of 3 plus 6 plus 3 plus 6, which is 18 units. B had a perimeter of 5 plus 5 plus 5 plus 5. That equaled 20 units. Then C has a perimeter of 4 plus 5 plus 4 plus 5, which equals 18 units. So you'll notice that A and C both have the same perimeter. There's a cool thing here. This is what mathematicians look for. They look for patterns. Notice that 3 plus 6 is 9 and 4 plus 5 is 9. That is why they have the same perimeters. Okay, in number 5, draw a rectangle that has the same perimeter as rectangle A and a different area than rectangles A, B, or C. So I needed to have a rectangle with the same perimeter as rectangle A. So let's go back up here. Rectangle A has a perimeter of 18. So this is where I use my table. I know my perimeter has to be 18. Since 18 is the same thing as 9 plus 9, I found a length and a width that equaled 9. I could do 1 plus 8. I could do 2 plus 7. I could do 3 plus 6 and 4 plus 5. There are actually 4 different rectangles that I could make that have the same perimeter of 18. Now I have to find one that has a different area than A, B, or C. So that one's a little bit tricky. So I can use any of these as far as perimeter, but which one has a different area? So I found all their areas. 1 times 8 is 8, 2 times 7 is 14, 3 times 6 is 18, and 4 times 5 is 20. So let's look at what ones we already have for area. Rectangle A is 18. I can't use that one. I have to have a different area. I also have an area of 25. Oh, no areas of 25. Okay. I also have an area of 20, so I can't use that one. That leaves me with 2. So in our drawing here, you should have either a 1 by 8, or remember that can be an 8 by 1. 1, 2, 3, 4, 5, 6, 7, 8. You could have this rectangle, or you could have a 2 by 7. 1, 2, 1, 2, 3, 4, 5, 6, 7. Or you could have that one. So there's 2 different choices for you. You could have a length of 1 and a width of 8 and an area of 8. Or you could have a length of 2, a width of 7, and an area of 14. Either one works. Okay, and in number 6, find the side lengths of 2 different rectangles that have a perimeter of 20 units. Then find and compare their areas. Now, since I was making a table, I found more than 2. But you can see what 2 you found. You should find your 2 in my table. So notice that I have to have a perimeter of 20 units. Remember, 20 units is a 10 plus 10. So my length and width have to equal 10. Then my other equal length and width will also equal 10. So I looked for all the different ways I could make 10. I have 1 plus 9, I have 2 plus 8, 3 plus 7, 4 plus 6, and 5 plus 5. So all of these will give me a perimeter of 20. If you want, you can go and double check. 1 plus 9 plus 1 plus 9 is 20. 2 plus 8 plus 2 plus 8 is 20. 3 plus 7 plus 3 plus 7, 4 plus 6 plus 4 plus 6, and 5 plus 5 plus 5 plus 5. Those are all perimeters of 20. So then I have to find not only 2 different rectangles that have a perimeter of 20, I have to find and compare their areas. So what do you notice about all of their areas? They're all different. Now I want you to look at which one has the largest area. Our largest area again is our square. That's interesting. That's been happening almost every single time. Okay, it has been happening every single time because there's a reason for that. So notice that when I have a square, it has the largest area. Which one has the smallest area? Our long skinny one. If I have a 1 by 9 or a 9 by 1, ooh, I don't know how to do 9. Okay, so there's 9, and then let's see. There we go. I think I did it. 1, 2, 3, 4, 5, 6, 7, 8, 9. A length of 9. My area is only 9. So notice every time the greatest area is always the square. And our smallest area is always the long, skinny rectangle. That's interesting. We'll have to talk about that more later. Okay, that is the end of our session 4. I'll see you for session 5.